Okay, well, the previously recorded video didn't work out so well, so I've brought up the test on the Wilcoxon two-sample t-test or two-sample test, and you can find there are a bunch of these out there on the web. The disc that comes with your statistics book that has a mini tab on it that has all these tests on it also. So if you ever find yourself needing to do this, you don't have to do it manually. There are plenty of tools that you can do it with the computer. This calls it the Wilcoxon two-sample test. As we've talked about, it could be Wilcoxon or Mann-Whitney U or any combination of those. But I did put in those values, 28, 43, 56, 58, 59, 71, and 23, 29, and 38 over here. I clicked on submit, and it gives me these results of A is 6, B is 3, the calculated W value is 8, and the probability is 0.095, probably because of a small sample size. You know, you can always go through. One of the things about this is you can go through and you can change these values. If this 38, for example, went down to 18, and then you submit that, you can see that this drops down to 0.04762. So, I mean, that's one of the neat things about going through and doing these programs like this. You could put in some value, you could change the values around, and then you could see how it changes those values. Okay, so let's go back to the video and pick it up where we left off. Okay, data types that can be analyzed with a Mann-Whitney U test or with the Mann-Whitney Frank or Mann-Whitney Wilcoxon test or whatever you want to call it. Data points should be independent from each other. Two samples are independent. Data doesn't have to be normal. The variances do not have to be equal. Those are assumptions of the parametric. All individuals must be selected at random from the population. A simple random sample. I've seen that lots through the course. All individuals must have an equal chance of being selection. Sample sizes should be as equal as possible, but you can have some differences. It's best in all tests if they're equal. Compare that with what would be analyzed with Wilcoxon matched pairs, the one that we talked about just before this one. The distributions don't have to be normal, and the variances don't have to be equal. Simple random sample, equal chance of being selected. The sample size have to be equal because it's matched. And should be used somewhere where both data sets have something in common. You know, measurement of the length of the left arm, the right arm, or the measurement of the test score on this one test versus the test score on this other test. Okay, the next test we want to talk about is the Kruskal-Wallis H test. 3 or more independent samples, and so, you know, hopefully you picked right up on that and say, aha, that's the parametric equivalent of that is going to be the analysis of variance. It uses the chi-square for its t-test or for its statistic, so this critical value is going to be in the right tail. Let's just do a quick look at what you would see on it. And again, you don't, there's a lot of these out there, so, you know, you can just do a quick search if you want to do one of these. So let's just put in some values here. Okay, I'm going to assume that that one didn't work out either since the previous one didn't work out. I'm not really sure what the challenge is there. So I'm going to break. I know this is probably a pretty short one, video, but I'm going to break here at this point and go back and make sure that this is all something that we can use before we get started too much in it. check with